This is a basic video demonstrating the operation of the VST Platinum CentralVac vapor collection system. This system collects fuel vapors from vehicles as they are fueling at a gas station. These are also known as transfer emissions. The system consists of the VST green machine, as well as the combination of nozzle, hose, and breakaway. The green machine is known as the back end, and the hardware at the dispenser is known as the front end. Here is a system-level view of a gas station with the VST Platinum CentralVac system installed. Note that there are both air and fuel vapor particles in the underground storage tank, represented by blue and orange dots respectively. Also note that the UST pressure, shown by the inches of water column bar, is at -2. This scene represents the starting conditions for our demonstration. Let's focus on only the front end of the system for now, the hanging hardware at the dispenser and the underground storage tank. Here we see a close-up view of the hose used in the system. The inner hose carries the fuel from the underground storage tank to the vehicle, and the outer hose carries the fuel vapor particles from the vehicle back to the underground storage tank. As the liquid fuel leaves the underground storage tank, it creates a vacuum that pulls the fuel vapors out of the vehicle. The vacuum in the tank is also improved by the performance of the VST green machine. The combination of the basic tank physics along with the green machine assures maximum vapor collection during the vehicle refueling process. Onboard refueling vapor recovery, or an ORVR system, is a feature that is becoming more and more popular in modern vehicles. This system, in the vehicle itself, captures fuel vapor, then burns the captured vapors in the combustion process. VST Platinum CentralVac system hanging hardware is compatible with both ORVR and non-ORVR vehicles. The ratio of vapor returned to fuel dispensed, also known as the A/L ratio, is a dynamic ratio in the VST system. For example, if a non-ORVR vehicle fuels, the ratio will be 1:1. This is because the only system recovering the vapor is the VST system. However, if an ORVR vehicle fuels, the ratio will be much less than 1:1, as the vehicle's onboard vapor recovery system will recover most of the vapor. Then, the system shown here will collect any vapor not collected by the vehicle. In the case of this example with an ORVR vehicle, fewer vapors are returned to the underground storage tank. The underground storage tank will be left with a vacuum level that improves the overall operation of the system. Now, let's take a closer look at the operation of the nozzle. To ensure that the air can't enter the system, the VST nozzles have a patented articulating faceplate. Note that this articulating faceplate allows for the nozzle to have a good quality seal with the vehicle's fill neck at all times. This range of motion is unique to the VST nozzles and assures a tight seal for virtually all vehicle refueling systems, which maximizes efficient vapor collection. Added to this design is the VST patented interlock that guarantees a tight seal before the fueling process can begin. This feature assures maximum transfer emissions collection and control. As an added feature, the nozzle ceases to work when the interlock is broken or damaged, which assures that it is always functional at its highest performance level. When the lever on the nozzle is activated, the liquid fuel flows down the vehicle's fill neck to the fuel tank. At the same time, the vapors in the vehicle's fuel tank are returned to the underground storage tank. Note that at no point during the fueling process does the outside air have a chance to enter the system. Air entering the system could possibly cause the UST to pressurize, increasing the risk for fugitive emissions. Overall, the VST Platinum CentralVac system collects all available fuel vapors from vehicles fueling at a gas station without ingesting unnecessary air particles. Ingestion of any air into the system merely adds to the problem of overpressurization by encouraging vaporization. The VST system works to reduce the ingestion of fresh air into the system, thereby minimizing vaporization and overpressurization of the underground storage tank.